Okay, now just a short video on problems with polymers. So there's no quick quiz for this one today. So problems with polymers. So the first problem is availability. Can't spell. Availability of starting materials. So what does that mean? Well, what are the starting materials for polymers? So we mostly make them from alkenes. Alkenes come from the cracking of crude oil. So we take our long bitumen chain, we crack it to make a shorter chain that we use as a fuel, and then it also gives us an alkene. And then we use alkenes to make polymers. But because ultimately it's all come from crude oil, so crude oil is a finite resource. It is running out. So it's definitely a problem because we're going to run out of it. Right. Next problem. Persistence. As in it doesn't go away, right? Persistence in landfill sites. So when we chuck all this plastic away, it stays in landfill for an incredibly long time. And the reason it stays in landfill for an incredibly long time is because they are non-biodegradable. So they don't rot, they don't break down, right? So all this plastic in landfill sites persists there. It hangs around there for thousands and thousands, tens of thousands of years because they don't rot. We don't use the word rot really. They are non-biodegradable. They do not break down, which means they take up loads and loads of space in landfill sites. Also a problem. And we can obviously get rid of that problem if we just, set fire to it, solve our problems with flame and fire. But then that causes us another problem because if we burn them, so this is the gases produced by disposal by combustion. So gas is produced by disposal by combustion. Remember, combustion's our posh fancy word for burning. So we can burn all this plastic instead. But the problem with burning it all is some of the gases it produces are greenhouse gases, which isn't great because greenhouse gases contribute to global warming, which is its own massive, huge issue. The other problem is a lot of the gases produced from burning plastics are toxic, and so they need to be removed and filtered from chimneys like incinerators before that gas is released into the atmosphere, because otherwise it's toxic to living things, which isn't great. We can obviously solve a lot of this issue from recycling. I'm going to go on and talk briefly about that in a second. But part of the problem with recycling polymers is the requirement what is wrong with me? It's been a long day. Is the requirement to sort polymers before melting and reforming. So hopefully you know about lots of different polymers. We learned about those before. If you're just collecting all plastic waste, I know when you chuck it out of your house and into your recycling bin, you just go, brilliant, that's all the plastic stuff. But then actually when it gets to the depot, and it'll go to a specialist plastic recycling place, they have to sort through all the plastic into the specifics of the different polymers. You can't just melt it all because you just end up with a mess. So they have to put all the polyethylene together, all the polychloroethylene together, all of the polytetrafluoroethylene together, all of the polypropene together. And then when they melt that, they can then make it into new things, but you have to make sure you've got those individual plastics sorted. And it's not like sorting metals where you can, filter out the steel cans from the aluminium ones with a magnet or anything like that. This all has to be done by hand. I'm not sure I'm literally doing this live now. I'm not sure how well this will come out on camera, but if you take a plastic bottle and have a look at it, somewhere on it there should be a recycling symbol which will have a number in it, normally inside a triangle. I was going to try and show you this on camera. Yes, this is never going to come out, I don't think, but on the bottom of this bottle, yeah, that was hoping for a lot. Now maybe you can just about see it. Where am I supposed to be zooming into? Right, hopefully you can just about see that under my finger there. There is a recycling triangle with a number 1 inside it. So it's like, you know, your typical recycling triangle, and it's got a number 1 inside it, which means for the people at the recycling centre, they find that symbol and then they chuck it in like bin number 1. And I'm assuming that is polyethylene. And then it might be, if there's a 2 inside of it, it means it's polypropylene, so it goes in bin number 2. Or if there's a 3, it's a different polymer. Have a look at some of your plastics at home, like plastic that's like typically designed to be recycled, right? So find a plastic bottle, have a look on it, and hopefully you can see those. But the main thing is, if you imagine all the hundreds of tons of recycling, that all has to be sorted through by hand, which is a time-consuming process, which means it's actually quite expensive to do, because it's not just got to be collected from your house, it's then got to be taken to the main depot, then taken to a specialist plastic depot, and then you've got to pay people to sort through it by hand and sift through it to separate it out into the individual bits, which makes it expensive. So 4 problems there with polymers, and that leads us on to, so you need to know about the pros and cons of recycling polymers. And I might be repeating myself from some of the stuff we've just done, but the 3 categories you need to know about are the economic implications, the availability of starting materials, and the environmental impact. So just to discuss these quickly in terms of pros and cons. Economic implications, right, that is a con, that is a negative, because as I've talked about before, recycling polymers is expensive, involves a lot of time, a lot of labour costs to collect it and then to sort through it all, so that it is quite expensive to recycle polymers, so that's a negative. Right, availability of starting materials, that is a pro. So we talked before, the problem with making polymers is they come from alkenes, which comes from crude oil. Crude oil is running out because it is a finite resource. Well, if you're making a load of this from recycled plastics, it's going to mean your crude oil lasts for longer. So it means the more you recycle, the less crude oil you need to use to make plastics, which means your materials will last for longer. So that is definitely a pro. Environmental impact, that is obviously also a pro, and it's going back to these reasons. If you chuck polymers away, they hang around in landfill sites, taking up loads of space because they're non-biodegradable. That's bad. If you try and burn them, they release all this nasty gas stuff that we talked specifically about earlier, which is bad. But if you recycle them, they're not going to landfill and they're not getting burnt, which means it's better for the environment. And thus concludes the video on the problems with polymers.